here are sum and difference of perfect cubes. In our sum and difference of perfect cubes, we had the general form a cubed minus b cubed is equal to a minus b times a squared plus ab plus b squared. And our sum of two cubes is a plus b times a squared minus ab plus b squared. And to be able to use this general form, we just need to see what times itself 3 times is our first and second term. So with our x cubed and 64, to find out what value is going to be in place of a and what value is going to be in place of b for the difference of two cubes, we just need to see what times itself 3 times is x cubed and what times itself 3 times is 64. Well, x cubed is just going to be, well, x. Because x times itself 3 times would be x cubed. Now with 64, we can go 3, second our x root, and see if 64 is a perfect cube, and that would be 4. Because 4 to the third power is 64. So the term that's going to go in place of a in the general form would be x, and the term that's going to go in place of b is 4. So here the general form for the difference of two cubes is a minus b times a squared plus ab plus b squared. And we can start with the a term, because the a term is going to be the number or term that times itself 3 times this x cubed, which in our case is x. So every a in this form is going to be replaced with x. So our first a here is just x. Our next one, the a squared, we replace the a with x. We still have the square, we still have those exponents, so it would be squared. Plus, this a here will also be replaced with x. And that's the only other place a shows up. Now we need to do the same thing with our b terms. And the b is going to be replaced with 4. So our first b here would be 4. There is no 1 with the x squared, but the middle term, we replace this b with 4. Plus, and we replace the b squared, or the b part, with 4. We still have our squared. And the last thing we need to do is we're going to simplify. Are there any questions on this, bless you, before we simplify? Now this first set of parentheses, there's nothing in front of the numbers, there's no exponents. So at the x we drop the parentheses, we still have minus, and we have the 4. Our next one is the x squared. We're multiplying x by itself, so x times x is just going to give us x squared. Plus, the middle term, we have x times 4, which is going to be 4x, plus 4 squared. 4 times 4 is 16. Telling us that the correct factorizations for x cubed minus 64 is x minus 4 times x squared plus 4x plus 16. And that's it. Questions on this here? So really this here, I would say for the most part, is we're just matching it up. We're using the formula to get the terms that we want. Yes, ma'am. So we use the plus formula for this one here, the a plus b times a squared minus ab plus b squared because of the starting form of the plus. Because our sum of two cubes, a cubed plus b cubed, is attached to this one here. And the one we just did, we started off with x cubed minus 64. So we're attaching this to our a cubed minus b cubed. So when we're subtracting two perfect cubes, we use the difference formula. When we're adding, we'll use the sum formula. Yeah, good question. Any other questions before we move on? (27a to the third plus 64). So when we look at this here, we do have a sum of two terms. Now the big question is or are these two terms perfect cubes? Can we rewrite them as a term times itself 3 times? Now, I would also be looking for greatest common factors, especially if we look at the cubics, the cubed roots of the numbers, and it doesn't come out nicely. There's a good chance there's a greatest common factor we have to pull out, we have to factor out. Now, for 27a cubed, our first term, we're looking for what times itself 3 times gives us this. Well, we can do the cubed root of 27, which is 3. And the cubed root of a to the third would be a, because a times itself 3 times would be a cubed. So what we're saying is 3a cubed, 3a times itself 3 times would be 27a cubed. Now we also need to see if 64 is a perfect cube, and it is. It's 4. We also did that just a minute ago, yes? Now to factor it out, the first thing I'm going to do is just write the general form. A plus b times a squared minus ab plus b squared. Now we are going to match these up. So in here, our a's, where a shows up, we're going to replace it with 3a. So in the first set, this first a is going to become 3a plus. I'm going to leave a space. For b, we'll plug it in a minute. Now, a squared, we're going to replace the a with 3a, telling me that I have 3a squared. Minus, we replace the a and ab with 3a. And that's actually the last a term. That's the only other one that shows up, yes? So with sum, it's going to end up being minus. So with the plus, so we're plus sum of two cubes. It's a plus b times a squared minus ab plus b squared. And the pattern for the signs, it's going to be the same, opposite, always end on a positive note. So it's going to be the same as what we started with. Since it was a sum, first sign is going to be plus. Second sign is going to be opposite. We're going to have to flip it. So it's going to be minus. And then it always ends on a positive note. Plus. Any other questions? Now our b term is 4. So in the first set of parentheses, we just have 4. We're not going to have it with our squared term. There's no b term that shows up here. The middle term, we have b to the first power, so it's just going to be 4. Plus, in the last spot, it is b squared. So we'd have 4 to the second. And if we're looking at this, and especially these terms in the first set of parentheses, sign's the same as what we start with. First term is going to be the first term that shows up. What times itself 3 times, that would give us that. In this case, it's 3a. Second term is also to that first power. What times itself 3 times gave us 64, which is our 4. In the bigger one, the first term, that 3a is going to go squared, first, no term. No first term, or really to the 0 power. The second term in the bigger one is we don't have it, For the first square, its exponent's increasing. Now the last thing we have to do is simplify. Now our first parentheses, we can just drop the parentheses, it's 3a plus 1. In the bigger set of parentheses, we are going to have to simplify the 3a squared. I've seen it a number of times. We will write 3a squared. We're actually multiplying it by itself. So we're squaring not just the a, but we're also squaring the 3. So 3 squared, 3 times 3 would be 9. 9a squared. Minus. Now we're going to have to multiply the 3a and 4. Well, our 3 times 4 is 12a. Plus 4 squared is 16. And that's it. And the 9a squared minus 12a plus 16 is not factorable in any possible way. It kind of looked like it there at the start, 9a squared, 12a, greatest common factor of 3. But then 16 gave us the common term. There's no greatest common factor. Questions on this here? We ready for the next one? With this one here, we have 192x cubed minus 81y cubed. So looking at this here, we do have the possibility of a difference of 2 cubes, is what we have. In the general form, we'd have a minus b. The sign would be the same. And then in the bigger, we'd have a squared, opposite sign. A is going to be now to the first. B is also to the first. Always ended on a positive note. Our second term is squared, first term not there. Now we need to figure out what A and B are, what's going to go in those places. And to do that, we need to see what times itself 3 times. If there is a term times itself 3 times, that gives us 192. That's not too bad. We can take the cubed root of 192 and we get a decimal. So it's telling me it's not a perfect cube. I can check the same thing with 81. It's telling me it's also not a perfect cube. So what I'd want to do is go back and look at those two numbers specifically and see, is there a common factor? Is there a number that goes into both, 192 and 81? 3. So if I factor that 3 out, if we factor 3 out of 192, we divide it by 3, we should get 64. And we'll still have the x to the third. If we factor 3 out of 81, we divide 81 by 3, we get 27 y to the third. Okay, now we know that these two do factor. We've seen 27 and 64 up to this point, yes? The 64x to the third, well, that would be 4x, because 4 times itself 3 times is 64. X times itself 3 times is x cubed. 27y cubed. 27 would be 3, and y cubed would be 1. Questions on this here? Now we need to start factoring this here. Now the a minus b times a squared plus ab plus b squared is the general form for a cubed minus b cubed. Yes? Now one thing we do have to add to it is the greatest common factor, which was 3. We have to put it out front. Because we factored it out front, we're going to put it out front. Because really that general form is now not looking at our original problem. It's mainly looking at the 64x cubed minus 27y cubed. We put the 3 out front to signify that greatest common factor we pulled out. Now our a term in our case is 4x minus our b term, which is 3y. First spot in the bigger one is a squared, and our a value is 4x. So it would be 4x squared. Plus, in the middle, we have a times b. Well, a is 4x, and b is 3y. And our last spot is b squared. So it'd be 3y squared. So really the big thing with this is just figuring out what's a and b and replacing it in the formula. Questions on how we got to this point here? Yes. So we have 3 times. Now this first parentheses, with our 4x and 3y, we can drop the parentheses, giving us 4x minus 3y. 4x squared, we have to square both terms. Our 4 squared, 4 times 4 is 16, and x times x is x squared, giving us 16x squared. Plus 4x times 3y, well the 4 times 3 is 12, x times y is xy. Plus, our last term is our 3y squared. We do have to square both the 3 and the y. 3 squared is 9, and y squared is, well, y squared. And the nice thing with both the 4x being squared and the 3y being squared, because there's not a sign in the middle, we don't have to do the full distributive property. We're just multiplying it by itself. 4x times 4x, 4 times 4 is 16, x times x is x squared. 3y times 3y, 3 times 3 is 9, y times y is y squared. And that's it. Questions on this here? Questions on anything we've done so far? We feel the sum and difference of t cubed is not as daunting as we thought. Especially once we see the pattern and how the pattern works, we're just following it every time, no matter what the numbers are. Let's go to this one here, because I think we've kind of got the hang of this, yes? What's the big difference between this one and the last one? They're in different places. Yes, we have a number in front, we have a constant, and the variable second. It's not going to change anything. It's not going to do anything different. It's just now that we're going to have a number taking the place of a. Because between the two terms, well, figuring out what b is kind of nice, because what times itself 3 times is x to the third? Well, it's just x. Now we do need to figure out what times itself 3 times is 125. So the term taking the place of a this time is going to be 5. The term taking the place of b is going to be x. And the general form for our difference is our a minus b times a squared plus ab plus b squared. We can go through and replace a with 5 and b with x. A squared would be 5 squared. A plus b would be 5 times x plus b squared would be x squared. And again, at this point, all we're doing is going and replacing a and b in all three spots. Now, in the first set of parentheses, we would end up getting 5 minus x when we simplify. In the bigger set of parentheses, first thing that we have is 5 squared. Well, 5 times 5 is 25. Plus 5 times x is 5x. And lastly, x squared is, well, x squared. And this here is one way we can write our answer. Now, for the most part, we normally like having the variables first, having variables, then constant terms, writing it in that order. But we can't just switch the 5 minus x, because x minus 5 is not the same as 5 minus x. Those are two different expressions. Because if I wanted to rewrite this so that x was first, we'd have to write it as negative x plus 5. I think 5 minus x is, yes, just fine. I think it looks a little nicer than having that negative out front. We can actually switch this around too if we wanted to. Really all we do is switch the x squared and 25. Now since they're both positive, it looks the exact same. It's that negative that kind of makes the front end of this different. These are both the same answer. There's nothing saying that we can't leave it as 5 minus x times 25 plus 5x plus x squared. That's fine. Questions on this here? We're ready to look at the last type of factoring. Two p squared plus 6p, or 2p cubed plus 5p squared plus 6p plus 15. The last type of factoring that we're looking at is called factoring by grouping. Factoring by grouping. I call it greatest common factor twice. So really, we can say twice or 3 times. And what we're doing with this kind of factoring, it is grouping them together and trying to take out common factors. And we do it in such a way that after we do it the first time, we can do it again. This works with even sets of terms. So here we have 4 terms. It works with 4 terms, 6 terms, 8 terms, as long as I can group an even amount or have it set up where we have an even number of groupings. And the way this works is it's kind of interesting that it does work this way. I'm going to group the first 2 and second 2. 2 groups of 2. And I'm going to look at the first set of 2 terms, 2p cubed and 5p squared. And look for common factors between those 2 terms. Now, 2 and 5, there is no greatest common factor between those 2. But they both have the variable p. So what I can say is p squared is a common factor between 2p squared, or 2p cubed, and 5p squared, yes? And if I factor p squared out of 2p cubed, we still have the 2, but the p is going to go from p cubed to just p. We can see that there, yes? Plus, if I factor p squared out of 5p squared, we're left with plus 5. We good with this so far? Let's look at the second 2 terms. 6p plus 15. What is the greatest common factor between, well, really 6 and 15? It will be plus. Because what are numbers that go into 6? Well, 2, 3, and 6, yes? We'd also look at 15 with those. Well, we know 15 is not divisible by 2 or 6, but it is divisible by 3. So I'm going to factor 3 out of both of these terms. If I factor 3 out of 6p, 6 divided by 3 is 2, and we still have the p, yes? If I factor the 3 out of 15, 15 divided by 3 is going to be 5. So when I factor the 3 out, we get 3 times 2p plus 5, yes? Well, wait a minute, what do we notice about those two expressions now? We factored it, and we ended up getting 2p plus 5 in common in both, yes? So now these two expressions have a greatest common factor of what? 2p plus 5, yes? And we're used to using greatest common factors with a single number term, not so much a whole expression. But there's nothing that says I cannot factor 2p plus 5, this whole expression, out of both terms. Because if I factor it, I pull it out of the first term, what are we left with? P squared, yes? And if I factor 2p plus 5 out of the second term, we're left with what? 3, and it would be plus. And we get 2p plus 5 times p squared plus 3. Now, looking at these two terms, 2p plus 5 is not factorable from there. Because when I look at that there, 2p and 5, do they have a common factor between them? No. And what's the degree of 2p plus 5? 1. So it's simplified as it gets. If the degree is 1, there's no common factor to it. It is simplified. P squared plus 3, the degree is 2. Is there a common factor between p squared and 3? No. It's a sum of two numbers. So it could be, well, it can't be a sum of squares. We don't have it. So this is factor. So that's all there is to factoring by grouping. We're grouping the terms so that we can pull a common factor out, so that what's remaining in both sets of parentheses is the same. And then we factor that out. Questions on this here? Three n cubed minus 4n squared plus 9n minus 12. We're going to do this one. We'll have to finish this up tomorrow. We ran out of time. That's fine. But I want to look at this one here first. Now, with most every single one we're going to do, we can group first two terms, second two terms, first two terms, our second set of two terms together. Okay. Now, if we look at this here, our first two terms, 3n cubed minus 4n squared. What's the greatest common factor? N squared. Which is going to leave us with 3n minus 4. So, we know that's the greatest common factor, yes? If we're going to be able to do it again, if we're going to factor this by grouping, I know that the second set of parentheses has to be what? The same thing, yes? So we know I'm going to have to factor something out of 9n minus 12 to get this here, yes? Because if it gives me anything else, we can't factor it out. Yes? We can even look at it. What's common between 9n and 12? 3? You're good. And we know that it has to be positive, because if I factor 3 out of positive 9n, we'll get the 3n that we want. If I factor 3 out of negative 12, we'll get the negative 4 that we want. So I point this out also because sometimes it's hard to see what common factor we need to pull out or what the common factor is. So if there's one of the two sets where I can see what that common factor is easier, or I can see it faster, I start there because it gives us a hint at what the other has to be. And then the last thing we need to do is factor 3n minus 4 out of both, leaving us with n squared plus 3. Questions on this here? Yes? You will be able to for these here. I'm not going to give you one that doesn't, because then it starts getting a lot more complicated. Yes. Sometimes it might take a few times trying to see it, but we will be able to do these.